Hi, and welcome back. So let's take a look at how we can make objects, so instances of our classes, callable. Let's do a simple example first. Let's start with this person class, and I'm only going to define the call method. And all I'm going to do here is just basically print out that call was called. Okay, so that's all we're doing. So now, of course, the class itself is callable, but it has nothing to do with this call method. And now I have an instance. As you can see, the call method was not called. But now the object itself, the instance, is itself now a callable. So I can call it, and as you can see, now the call method was called, right? But the type of P is a person object. So that's why in Python in general we talk about callables. We don't necessarily talk about functions because things other than functions are also callable. So methods are callables, right? Classes are callables. And in this case, a person instance is a callable. So this is actually really useful, and it's actually very widely used. Making classes that are callable happens in a lot of places in Python, and we don't necessarily realize it. We think of those things as functions, and often I'll even refer to them as functions, but they're not actually functions, they're just callables. So for example, there's the partial function that we can use that's in the functools module. Well, that's actually not a function. Let's go ahead and take a look at that. So you should already be familiar with the partial. That's one of the prerequisites for this course. So if we look at this, we can now look at, let's say, the type of partial. And you'll see that it's a type. So remember the type, if I look at the type of my person class, you'll see that it's type as well, right? So partial is actually a callable class. It's not a function per se. So if I define a function, let's say I define my func, and let's say it takes 3 arguments. I just want to show you quickly how we use the partial. So ABC. Now if I look at the type of my func, by the way, that is a function. Okay, so my func is callable, and it's a function. Partial is callable, but it's not a function. And P is callable, but it's not a function. So now we can call my func indirectly through partial. Let's say that we want to create a partial of my func that has the values for A and B predefined. So the way we do this, basically, is we say partial func equals partial. We tell it which function we want, and then we give it the arguments that we want to pass in. So those will be positional arguments. So partial func, now if I look at the type of that, that's just a partial object instance, okay? So it's an instance of the functools partial class, and it is callable. Now I can call partial func, and I can pass it, let's say, 30. So what's going to happen is that partial func is going to call my func with 10 and 20 and then pass in 30 as well. And so we get the result that it returned the tuple 10, 20, 30. So again, I refer to partial as a function, but it's really just a callable in general. So let's take a look at a simple example of how we could recreate a simplistic version of this partial class or this partial callable. Let's go ahead and create it. So let's create a class called partial. And here we're going to define our init. So for the init, what do we need? Well, it's going to be a method, first of all. It's a method, so we need self, but we need to pass in the function. And then I'm only going to use positional arguments. I'm going to allow passing in a variable number of positional arguments to the init. And then all I'm going to do here is basically store this in private instance attributes. So self underscore func is func, and self underscore args is going to be args, like so. And then I'm going to make my instances callable, and I will allow, again, passing in an arbitrary number of positional arguments when we call the instance. And then all I'm going to do here is basically call self._func, passing it the self.args. So self.args, remember, is a tuple that I received here. So I'm going to unpack them into individual positional arguments. And then in addition, I need to take whatever got passed in here, and I need to unpack them also as positional arguments. And that's it. That's really all I need to do. So now I can go ahead and create partial func equal to partial, and I'm going to take my original function that just basically prints out the tuples, and again I'm going to specify the first two arguments like so. So now type of partial func, of course, is an instance of my partial class, but it is also callable. So I can call partial func with 30, and as you can see, we get the same result. Now, if you want to find out if something is callable in Python, you can. There's actually a built-in function called callable, and you pass in basically any object, and it will tell you if that object is callable or not. So for example, I can pass it the print function, and that is a callable. I can also pass it, for example, the int function, and that is also callable. Now, type of int is a type, so it's a class. So when we do int this, yes, I talk about it and I refer to it as a function, but it's really just a callable in general. It's not actually a function directly. It's something more than just that, but it is a callable. And the same thing, if we look at the type of partial I showed you before, but if I look at the type of this partial class, that's type. If I look at the type now of my partial func that I created as an instance of partial, that's that, and it is callable as well. So I can say partial func, okay, that is callable. Now, of course, my class partial is callable as well, right? Because every class that we create is always a callable. Same thing if I look at the person class, that is also a callable, because we can always instantiate instances of the class, so obviously they're callables. But if I create this class person here, and I'm not going to do anything, I'm just going to pass. Now, the person class itself, of course, is callable, and if I create an instance of the person class and see if that's callable, that's going to be false, because it is not callable. I didn't implement the done-to-call method. So let's take a look at a more complicated example. So let's say that I have a problem where I need to implement some kind of caching mechanism. So I'm not going to implement the cache here. What I'm going to do is I want to implement a dictionary that I can use for caching. And moreover, what I want to do is I want to be able to keep track of the number of cache misses. In other words, I want to keep track of the number of times somebody requests an item from this cache dictionary when the item is not present in the dictionary. So to do that, I'm actually going to use a default dict. So that can be useful because if the key doesn't exist in the dictionary, the default dict will return an instance of whatever we specify as the factory for the default dict. So let's go ahead and just refresh our memory on this. So from collections, I'm going to import the default dict, and I'm going to create a function called, let's say, default value. Now, the factory function that we use, or the factory callable, I should be more specific here now that we've defined callables. The default callable factory for default dict doesn't take any parameters. So here I have a function that doesn't take any arguments, and I'm just going to return this as the value. So now I can create a default dict instance, so default dict, and I'm going to give it the default value function as my factory. So now, of course, if I try and get an element from the dictionary that does not exist, you'll see that I get NA. Now, if the element exists, let me put in d of b equals 100, and then I request d of b, of course, I get that value back. And then it behaves like a dictionary. We can look at the items in the dictionary, and as you can see, we have A that was set to NA because I requested this non-existent key. So it ran this function, it got whatever this returned, and put that as the value of the dictionary. So now what I want to do is I want to use this default value callable to keep track of the number of times it has been called, because now that would tell me how many times a non-existent key was requested from that default dict. So I could try maybe using a global counter and use that in my default value function. So let's see how you might try this. You might say miss counter equals 0. So now this is a global variable, and I'm going to redefine my function default value, and we'll now indicate that miss counter is a global. So that's from the global scope. And now, of course, we can assign values to it. If we didn't do the global keyword over there, we would be creating a local variable, and that's not what I want. I want to reference this miss counter from the global scope. And then finally, we'll return NA, okay, like so. So we could certainly do that. Let's try again creating the default dict. So we'll pass it the default value function as the factory. And now if I say DA, let's say equals 1, then I'm setting the value, so that's fine. And now if I retrieve DA, that's fine too. And my miss counter is still 0. I haven't had a cache miss yet. Now I request B. And of course, if I get B, I get NA back, which is the result of this function over here. And my miss counter is now incremented to 1. So this works, but it's really not very good. The default value function relies on us having a global miscounter variable. If we don't have it, our function won't work. That's one kind of downside to this. Now, additionally, we cannot use this approach to keep track of different cache instances. Maybe I have multiple caches and I want to do the same thing with this counter on all these default dicts. In this case, this default value is always going to be using the single miscounter. And so I would have to create another function that has maybe miscounter 1 and then miscounter 2 and miscounter 3 and so on. So this is not a good solution. It works, but it's really not very good. So maybe we can just pass in the counter that's defined in our current scope that we want to use to the default value function. Let's see. Now, let's just see this. Maybe we could try this approach first. So let's say default value counter. And all I'm going to do here is I'm going to increment the counter by 1, and then I'm going to return NA. So maybe we might try something like this. Now, I hope that at this point, what you realize is that this isn't going to work. The reason for that is even if I pass this global miscounter in as a parameter, right, of this, what is this going to increment? This is going to create a local variable counter. It is not going to use this one over here because this is a local variable. So this approach isn't going to work. And that's not the only problem. The other problem too is that the default value, this function that we pass into the default dict, cannot take an argument because it gets called without an argument. So we're going to have to find a different approach. This is not going to work. So let's remove it. So let's try a class-based approach. So let's do this, class default value. So I'm going to make an init. And the init doesn't do very much except create a counter in my instance and set it to 0. Next, I'm going to create the iadd method. I'm going to implement the iadd method. And this is what I'm going to use to increment the counter. So I can use an instance of that default value counter and say plus equals 1. And that's going to basically add in, call this with 1 inside other. So here I'm going to just do some minor checks. If is instance other comma int, so I need this to be an integer, then I will do self.counter plus equals other, and of course I have to return now the new value, but it's just myself. I'm doing a mutating operation, so I just have to return myself. And otherwise, if it wasn't, I'll just raise a value error. So if it wasn't an integer passed in, I'm going to basically say no, you can only increment with an integer value, let's say. Okay. All right, so we can use this class as a counter. Let me show you how we would work it. Let's say default value 1 equals an instance of default value. Now we can say default value dot counter, and we'll see, well, default value 1 dot counter, that's 0. We can also say default value 1 plus equals 1. And now if I look at the counter again, default value 1 dot counter, you'll see that that has been incremented. Okay, so we can use this as a counter. But default value 1 is not callable, which is what we need for the default dict. So let's make it callable. That's very simple. We can go back to this class. Let me copy paste it. And all we need to do is to add the call method. So dunder call. And what I want to do when we call this method is I want to add 1 to the counter and return the default value that I want for my default dict. So I'm going to do counter plus equals 1. So I'm going to increment this and I'm going to return NA. Okay, like so. So technically, I don't need to implement this iadd method because I'm only going to use it via the call where I'm going to increment the counter directly. I just wanted to throw it in initially to show you that we could use it as a counter over here. But it's not going to work, obviously, as is without the call for our default dict. So now that we have this class, let's go ahead and just test it out. So let's say def1 equals default value instance and def2 equals default value instance, right? So we now have two instances of this default value class, and let's say cache1 equals default dict, and I'm going to pass it def1 now. So I'm going to pass it an instance of my default value. This is a callable. It doesn't take any arguments, so it's going to work for the default dict. And it's going to have its own counter because it is an instance of default value, right? So it's going to have its counter. And then if I say cache2, I can do exactly the same thing, and I can use def2 here. So def2 is a separate object. It has its own counter because counter is an instance attribute, and it's also callable. So now we can call into our cache. So let's say cache1a, and then I'm also going to call cache1b, right? So this is going to be two misses on cache1, like so. So first of all, I get the correct default values back. That's what my call method returned, na. And secondly, I can now look at def1.counter, and that is equal to 2. I had two misses on the dictionary. Now, if I say the same thing with cache_2, let's say looking for a non-existent key, and my def2.counter is 1, right? Which is independent of the counter in def1. Okay, so that's kind of a simple example. Now you could make this a tiny bit more flexible. Let me show you. I mean, there's other things that we could do. One of the things that you could do here is actually specify the default value that you want in the init. And then here we just have to store that in an instance attribute. So default value equals default value. And then here, instead of returning na, we're just going to return self.default value. And in fact, we don't really need the iadd, so we can even take that out. And now we can use it this way. So cache def1 equals default value, and I'll make the default values here none. I can do another cache default, let's say, equal to default value with a 0. So that will be my default for that one. And let me fix my typo. And then we can create dictionaries. So we can say cache_1 equals default dict. We can pass it the cache def1. That's that callable. And then we can create cache2 to be default dict, and we can pass it the cache def2. So now we have our two default dictionaries. If I use cache1a and cache1b, then you'll see that I get none, right? That was my return, that was my default. Now obviously my cache def1.counter, that has a count of 2. But if I use it with the second one, so if I say cache2a, that returns now the default 0, which is what I specified as the default value here that I wanted. And of course my cache def2.counter is going to be 1, because I had one miss on that. So the call method can essentially be used to make instances of our classes callable, which can be very useful. They're also useful to create decorator classes. Now often we just use closures to create decorators, but sometimes it's easier to use a class instead, right? So if we want our class to provide functionality beyond being just a decorator, that might be another reason. So we have some complicated class, and then as one of the functionality of that class, we want to be able to use an instance of that class as a decorator for some reason. So let's look at some examples of that. Let's look first at a profiling function. So for simplicity here, I'm going to assume that we only want to decorate functions at the module level. I am not going to create a decorator that can decorate methods. We'll take a look at that later on when we start talking about descriptors. But it's a little different because methods are bound, and so we need to account for that when we create our decorators. So things get a little trickier that way. we have to implement, some other methods too. So I'm not going to look at that. I'm going to assume for simplicity that we're creating a decorator that's going to be used to decorate functions inside our main module here. So the example I want to look at is how do we keep track of how many times a function has been called and how long that function takes to run on average. So I want to be able to do a very kind of simple profiler. Now, we could certainly implement code directly in our function to do this, but if I need to do this for multiple functions, that's becoming repetitive code, and really there should be a better way to do it. And of course there is. A decorator is a very good tool for something like that, because a decorator essentially wraps our original function and it's able to do additional things. Well, I'm going to make it do a counter, so it's going to count how many times that function got called, and I'm also going to have a time to see how long the function takes to run, and then keep a running average of that. Now, I'm going to show you first a closure-based approach, and then we'll circle back and use a class-based approach. So I'm going to need to do some timing. So from time, import perf counter, and then from func tools, I'm going to import the wraps, because I'm going to be creating a decorator here. I'm going to wrap also. So let's go ahead and create the decorator, and we'll use a function to do that. So let's go ahead and do this. So we're going to create a counter. We need a counter, so let's do that here. Then we need the total elapsed time. So I'm also going to set that to be initialized to 0, and then the average time, and I'm going to set that to 0 as well. Next, I'm going to create my inner function. So this is going to be my closure, and to be as flexible as possible, it will take in a variable number of positional and keyword arguments. And of course, I'm going to use the wraps decorator just to clean up that closure, or that decorator, I should say. So now what I'm going to do is I'm going to run the function, but I also need to increment the counter, and I need to time this and then update the total elapsed and average time. This means that the first thing I need to do is to say counter plus equals 1. Right? Then I'm going to start, and that's going to be my perf counter. So I'm going to take a reading now. Then I'm going to call the function, pass it the arguments and the kw arguments. I'm going to store that in result. Then I'm going to take another reading of perf counter to get my end time. And now my total elapsed, right, is going to be the current total elapsed plus the end minus start, like so. And then I'm going to also calculate the average time, which is just total elapsed divided by the counter, right? The number of times this is run. And then of course I'll have to return the result. Now, we've got to be a little careful. What's happening here? Counter. Well, I want this counter object to be this counter over here, so it needs to use that cell. This is going to be part of the closure. This is a free variable. The problem is that I'm assigning to counter inside this function. So therefore Python says, oh, okay, it's a local variable. So I need to explicitly tell Python, no, I want to use a non-local counter. And of course I need to do the same thing for the total elapsed, and I need to do the same thing for the average time. Okay, so now we have what we need inside the inner function. And of course, to do a decorator, we return the inner function. But the problem if we return the inner function like so is that our user doesn't have access to counter and total elapsed and average time, at least not very easily. You can dig into the properties of the closure and try and get to that, but it's a pain. So I want to be able to give our users of this decorator easy access to counter and the average time. So you might try this. You might say, well, okay, inner is a function, so we can add attributes. So let's go ahead and add the counter attribute, right? This counter to the inner.counter, and let's set inner.average time to be equal to average time. So we might take this approach and try that. Now, I'll spoil this right now. This isn't going to work. And let's actually just try it out and see what happens. So from time, I'm going to import the sleep, and then I'm also going to import the random module. And that's because I want to sleep a random amount of time when I do a function call, just so I have some timing in the functions without having to write complicated code. I'm also going to use a random seed. I'm going to set the seed to, let's say, 0. I just want repeatable results. And so like this, every time I run the code, I will have the same run times. And I'm going to write a function. Let's call it func1. And it's just going to sleep. And it's going to sleep for a random amount of time between 0 and 1 seconds. And what I'm going to do now is I'm going to decorate it with my profiler decorator. And I called it profiles. So let me go ahead and fix that. Let's call this profiler. Okay, and let's decorate it like so. Okay, so now let's call the function. So I'll call the function and I'll call it twice, let's say. Like so. So let's wait for it to finish. Okay, so we had no result, no return because we didn't return anything from func1. But now let's look at func1, which is the decorated function, and let's look at the counter, right? It has a counter property. We can also look at func1 and look at the average time. And we get 0 back. What happened? Well, you have to realize that when we tied counter here to inner, to this function here, what counter was it? It was this variable over here, but it was actually the value. It was the object that counter was pointing to at that time. So now when I update counter over here, this counter is now pointing to a new object, let's say 1 or 2 in this case, right? By the time this finishes running, we should have 2. So counter is indeed 2 inside the closure, but this counter over here is still pointing to the initial 0. And then same thing for average time. So that's an issue, right? We don't want that to happen. Okay, so we can fix that. Let's go ahead and take this code. Let's paste it down here. And let's fix this. So what we want is somehow we want to return the cell, right? We want this to be basically the counter. Every time it gets updated, we want the new value for counter. Well, if you think about what's happening in this function here, that's exactly what's happening. It's always referencing the same counter that we defined over here. It's a closure, it's a free variable, so it uses this intermediate cell. And that's exactly what we want. So let's go ahead and do that. And we're going to use a function. So I'm going to create a function called counter. So now I don't want to have conflicts. So I'm going to call these things underscore. So all of these are going to become underscore. So let me just go ahead and fix that over here and here and here. We'll need it here as well. Start and total elapsed should be changed. And then average time is now going to use the total elapsed and the counter. So I'm just going to indicate those that way. And now I'm going to define a function called counter, and that's just going to return underscore counter. So now this is also a closure, and so this underscore counter here is going to be a cell that, the same as inner, points to whatever object, right, counter is pointing to. So this will work now correctly. And of course we can do the same thing with average time. So we can say average time, return underscore average time. We have these functions that are now attributes on the function inner that gets returned. So now let's go ahead and try this. So just as before, I am going to call it. So let's go ahead and redefine. So profiler func1. And now I'm going to call func1 again. I'll call it twice. So it's going to run, returns none. That's great. And now I can look at func1 dot counter, but of course counter is a callable in this case, so we get 2, which is correct. That's the number of times I called this function. And then we can look at the average time, which happens to be that. So this works, but it's really kind of convoluted, right? Look at this. We had to write 3 closures in here. This is going to be our returned one for the decorator, so that's what we return inner, but we add 2 more attributes, which are basically callables to inner before we return it. This, by the way, tying things like this is a pretty standard approach with decorators. For example, when you do the generic dispatch, right, the single generic dispatch, you'd have the same approach over there. So this is nothing new, but it's kind of convoluted. It's a lot of code, and it's difficult to kind of read and understand what's going on over here at a glance. So a much easier approach is to actually use a class to do all this. And let me show you. Let's go ahead and call this class profiler. And I'm going to do an init. So it's going to take in the function as its argument in the init. And then here I'm going to set counter to 0. I'm going to set the total elapsed to 0. And I'm going to set the function to the function. Another thing, by the way, that I want to point out is that here we're calculating the average time every time. We could probably be more lazy about this, not do this here, and return instead over here elapsed divided by that. So we could do that over here. Then we don't need average time. And then we don't need average time over here either, okay? Because we can just basically calculate it as it's requested. This would be a little bit more efficient. So I'm going to follow the same approach here. That's why I'm not storing average, time as an attribute, because I'm just going to calculate that. So now we have this init, so we can create instances of profiler, passing it the function that we want to decorate. Next, we want to make, therefore, instances of this profiler a callable. So let's go ahead and make it callable. So we define the call method, and it's going to take an arbitrary number of arguments and kw args, okay, like so. Now, this is going to be what gets called when I call my profiler instance. And what I want to do here is I want to increment the counter by 1. I want to start and take a reading of my perf counter. So we'll do that. Now I'm going to do basically the same thing that I did before, right? I'm going to call this function that got passed into the initializer of the class, and we'll pass it the arguments that we receive now when we call this. So we'll pass that, then we'll again take a reading of our perf counter, and then self.total elapsed, so total elapsed plus equals n minus start. We're going to tack that on, and then we're going to return the result. So if you compare this call method to this inner method over here, we're essentially writing that, right? So this inner method, we basically implemented in this call, or this inner closure, I should say, we implemented here in the dunder call. The next thing I want to do is I want to create a property. It's going to be a computed property, and it's going to be my average time, because I do want still that. And therefore, I'm going to calculate it here, and I'm going to return self.total elapsed divided by self.counter, like so. So now we can use profiler as a decorator. Okay, let's go ahead and use it. So profiler, func1, a comma b. And then I'm going to sleep, again, just a random amount of time. And then I'll just return a comma b, just so I have a return value. Now, let's see what happened. Let's try and understand this. You should already understand this, but let's make sure. So I have this syntax profiler. So remember that I could have done it this way as well. I could have just defined my function, right? Because that add syntax is nothing more than doing this. Func1 equals profiler func1. Okay, that's what that add syntax does. It basically did this line of code for me. So what did we do? Well, we created an instance of profiler, and we passed it the function that was in memory somewhere that currently has a name func1. That gets stored in the class, in the instance attribute fn, right? And the instance also has counter and total elapsed. So now profiler isn't, this func1 here gets reassigned. This profiler is an instance, right, of my profiler class, and it already knows what the function is. And now I can call func1, right? I can call func1. Now the type of func1, by the way, is just a profiler instance, but it is callable, right? Func1 is callable. And if I call func1, what is it going to call? Well, first of all, I need to provide it some arguments, because func1 expects, so let's say 1, 2. But what is that going to call? Well, it's going to call the dunder call method, right, of my func1 object. So it's going to increment its counter. It's going to start the timing. It's going to run this original function, func1, passing it the arguments 1 and 2, and then it's going to do the rest of its stuff and return the result. So let's see what we get. And we get the value 1, 2. We get this tuple back, right, from func1, but in addition, func1 now has a counter as well, because that's a class instance, and it also has the average time property that I can call and get the average time. And if I call func1 again, So let's call it with 10 and 20 this time. Then you can see that func1's counter has, of course, been incremented. And so now we have a 2. So as you can see, this was pretty straightforward to write a decorator using this class, and it's much easier to understand what's going on, right? We have this property over here, we have these attributes, we have the call method that becomes basically what gets run instead of our function. So this profiler is essentially a decorator class. So as I mentioned, we can just use the shorthand notation. So we can go ahead and let me redo this over here. But instead of doing it this way, I'm just going to decorate it using the syntax for decorators. So @profiler, and it's going to do essentially what happened here. So now we have func1, which is decorated. And again, we can just call func1, let's say 1, 2. Let's call func1 again with 2, 3. And let's call it one more time with 3, 4. So func_1. So now we ran that 3 times. And now we can call the counter, or we can look at the counter attribute. And then we can also look at the average time property. And as you can see, we get those values. And of course, it's a decorator, so we can use it for other functions as well. It's not just for function 1. We can use it for any function that we want to profile. So let's say func2, and I'm just going to do the same thing here. Sleep random.random. So now when I do that, then I can call func2 a few times, func2, let's say twice, and then we'll see that func2 has a counter of 2. Okay, like so. Now, of course, if your decorator is simple, just use a functional approach. That's my preferred way of doing things. I try to use functions and a functional style with Python whenever I can because it's much simpler to understand, right? Classes are nice to have, and they're sometimes very useful. As you see here in this case, it actually makes a lot of sense. But just because you have a hammer doesn't mean that everything's a nail. Just because you have classes in Python doesn't mean everything is a class. This isn't Java, this is Python. We have both functional and object-oriented approaches that we can use. And so we should use whichever one is the easiest to write and read. Readability counts. Readability is really important in programming. You can write very complex code, very complicated code that nobody else can read, can understand. And when you do that, it makes it very hard for someone to help you on a project or to debug your code or to take over from you later on. So I'm going to get off my soapbox. But in this case, though, using a class makes a lot of sense. All right, thanks for watching, and I'll see you in the next video.